Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. We have a 3 times 3 matrix A, whose third row equals the sum of the first 2 rows. We'll use that single row relationship to predict when solutions exist, and we'll see elimination expose the dependency directly. Think of AX equals B as 3 dot product equations, 1 per row. The key fact is that equation 3's left-hand side is built from equations 1 and 2. Because dot products distribute over addition, the third left-hand side must always equal left side 1 plus left side 2. That means the right-hand sides must also be compatible, or the system contradicts itself. Now, we test a specific right-hand side to see if a solution is even possible. Any solution would have to satisfy all 3 equations at once. Let's add the first 2 equations exactly as the hint suggests. By the row condition, that sum is forced to equal the left-hand side of equation 3. So it would have to be both 0 and 1. Impossible. No solution exists. One counterexample right-hand side is enough. If sum B has no solution, A cannot be invertible. Now we keep B general and ask, what condition must B satisfy to avoid contradiction? Adding the first 2 equations again gives a requirement on the right-hand side. Because row 3 is row 1 plus row 2, the left side must equal equation 3's left side. For consistency, B3 has to match B1 plus B2. So the solvable right-hand sides form a specific set. Every B whose third entry equals the sum of the first 2. Visually, solvable B's lie on this plane. The point 001 sits off the plane, so it can't possibly be produced by AX. In elimination, we can explicitly remove the dependence by subtracting row 1 and row 2 from row 3. Since row 3 equals row 1 plus row 2, this produces a 0 row in the coefficient matrix. So whatever we do to the rows of A, we must do to the corresponding entries of B. The entire third equation collapses into a single consistency check. If the right-hand side matches the dependency, the third equation adds no new information. If it doesn't match, elimination exposes the contradiction instantly. No solutions. The whole story is linear dependence. The third row doesn't bring new information. One impossible right-hand side proves A can't be invertible. Only B vectors on that plane can possibly work. Elimination turns the dependency into a 0 row and a clean consistency condition. Hit play on the next video and keep the momentum. There's a clever new twist coming that'll make these patterns feel instantly recognizable.